Okay, since we have a pedigree or a couple pedigrees to draw here, I'd like to try and save you time by just providing the drawn pedigree rather than making you sit and wait while I draw things out. But if we want to look through some background in here, pedigree, it's one of my favorite activities to go through in studying the genetics unit because it's sort of fun to track the passage of genes and thereby their subsequent traits through a family tree. Now, a couple things to remember. Squares represent males and circles represent females. If the individual has his or her symbol shaded in, that indicates that the person is affected or the person has the trait of interest. And if the person's symbol is left empty, then the individual is unaffected. Now, matings between individuals are represented by horizontal lines connecting the male and female. And then parents are connected to their offspring by vertical lines. Now, sometimes you need to split those vertical lines to have space for individual kids, but again, parents are connected to their kids via vertical lines. Now, what you'll be asked to do on the test is to determine a particular pattern of inheritance, or your book may refer to it as a mode of inheritance. That's basically asking, is it dominant or recessive? Eventually, you may be asked to determine if it is autosomal or sex-linked. Now, after determining the particular pattern of inheritance, then you'll be asked to identify the particular genotypes of individuals and consequently the probabilities of certain individuals being affected with the trait of interest. Now, I would suggest paying particular attention to figure 14.15 in your text. Now, here we see a particular pedigree. Again, to practice, what you'll be asked to do is figure out, is this dominant or recessive? Now, let's take these two individuals here and think about their potential genotype. If this is a situation in which these individuals are affected by a recessive allele, now don't write this down, just look. If both of these individuals are affected and it's recessive, consider what that would mean for all of their offspring. All of their offspring, since their parents are homozygous, all of the offspring would also be affected. Now, since that is not the case, we can assume that this is not a recessive condition, and instead it is a dominant allele or dominant trait, meaning that affected individuals will have a dominant allele. So we know these individuals have a dominant allele. Now, the question becomes, are they homozygous or heterozygous? If the individual is homozygous, and again, don't write this down, if the individual is homozygous, then that means this male would pass on a dominant allele to all of his offspring and therefore causing the offspring to all be affected. That's obviously not the case. So neither the mother nor the father can be homozygous for the dominant allele. Therefore, we know that these individuals have to be heterozygous. Now, unaffected individuals, they're easy enough to determine because since this is a dominant trait, the only way you're unaffected is if you are homozygous recessive. So anyone who has a shape that is not filled in is going to be homozygous recessive. All right, we know that this individual is affected, so this individual has a dominant allele. And then we can look at the offspring of this individual. Again, if this person was homozygous dominant, then all of her offspring would have the trait. Again, that's not the case, so she must be heterozygous as well. The last person we're going to look at is this person down here. Now, obviously, she's affected, so she has a dominant allele. And the question becomes, what is her other allele? And we cannot determine that given the information in this pedigree, because both parents, since they're heterozygous, could also have passed on to her a recessive allele. All right, let's look at one other quick pedigree. This is a quick and easy one here. So here we have mom and dad having 3 kids. Daughter that's affected, a son that is unaffected, and then another son that's affected. All right. So, considering this pedigree, these 2 offspring are affected, but their parents are not. Now, if this was a dominant pattern of inheritance, the only way these kids will get the trait is if one of their parents passed on a dominant allele to them. So that indicates to us that this must be a recessive condition, and for that reason, these individuals must be homozygous recessive. Now, these two individuals, the parents, do not have the trait, so they will have a dominant allele. But the only way that their offspring could possibly get two recessive alleles is if they get a recessive allele from each parent. Okay, that only leaves us with the middle child here. We know he doesn't have the trait, so he'll have a dominant allele. But again, mom and dad both possess recessive alleles, so there is the possibility that this child could also inherit a recessive allele and be a carrier for that condition. So again, these are the types of questions you'll be asked to complete on the quiz and test, so make sure you get a little bit of practice with that. Good luck.